Alrighty, welcome to the Conner equation part 4. Here we are going to focus on HB plus HC, that part of the Conner equation. First thing I'm going to do is fix this. This, I totally meant, oh boy, to be omega. That's fine, alright, because of course that's the whole trapezoid. So that is omega. And then the little parts, those are alpha. Alright, whatever. First thing we're gonna do HC first, okay? Just bear with me. Alright. So HC alpha, alright. We're gonna use summation notation. This time it is because we need to use summation notation. We are adding up the positive and negative heights to orient ourselves, height-wise, really, right? We're gonna, in this, we're gonna put alpha, just regular alpha, and here we're gonna put k equals 1. So we're gonna sum up SL times the sine. It's gonna be SLK times the sine of phi k. I'll input 5k. Let's do it. K. And that's it. This is HC alpha. What this is, let me of course explain. What is this? What is this exactly for anyone who might be confused? This is, you see the dotted line here? This is what this is on this side. So, okay. So this side, this is angle 1, right? Phi 1. Right, theta 1 equals phi 1, right? This side right here, I hope you guys can see all right. This side is SL1, okay? So what this is doing, we're getting this height, which will be, of course, perpendicular. It's going to be a right angle, because that's how sine works. It's going to be perpendicular to our little base here, of course, because this is the angle relative to the positive x-axis. Of course, sine, you get your, it's going to be perpendicular to your other side, so to speak, whenever you do sine. And of course, what this is, this is actually useful, the k equals 1 here is very significant. It's not k equals alpha. This isn't like a thing we need to sum this up, because what's going to happen when you get to phi 2 and SL2 is it's going to have its own thing relative to the positive x-axis. And what we want to do is we want to get the total height from the end of the side all the way down to our base of operations, the positive x-axis. We want to get all the way down. I'm going to draw over this. Yeah, bear with me. I want to get all the way down there. Well, what is this entire length? It is simply this length, this perfectly vertical length, plus this perfectly vertical length, and that's going to equal this perfectly vertical length. The end of SL1 is the same thing as the beginning of SL2. That's why this works. And you're going to do the same thing around the polygons. I'm going to extend this. So this side, we're going to subtract. It's going to be a negative value. It's going to be, look at this. This is going to be a negative sine value. I don't know. I'll draw the angle relative to the positive. That's the angle relative. It's kind of bad. Angle relative to the positive x-axis. So it's going down. It's going down into kind of the negative side of the unit circle, and so we're subtracting. It is going to be we're subtracting. It's like adding a negative, subtracting, right? And we're just going to do that all the way around the unit circle. I hope you guys can understand that. That is what we're doing. It's that simple. Now I'm going to show you. I'm not even going to do too much here. We're going to get HB now. HC is height clockwise, because we're going clockwise around the polygon, and HC is clockwise of HB, right? So that's the kind of nice little thing how I like to think about it. So if this right here is HC, then 0, HB is 0 for, it's always 0 for side length 1. HB will always be 0. But here, what is HB for SL2? For SL2 and phi 2, what is HB? Well, it's simply the previous HC, right? Oh, well, I wrote this and then I didn't finish writing it. So the difference is, I can even write it here. It's going to be -1. That's it. This is it. So it's the previous, the HB, right, is just whatever the HC was for the previous side. So for SL2, HB is just HC1. So HB2 is just HC1. So for this length, HB, which will be HB3, HB3 is just going to equal HC2. So that's the way it works. Okay, I hope you guys can understand that. HB is just the previous side. What the HC of the previous side was. That's all HB is. HB is the previous HC. Okay? That's why we do alpha -1. Little quirk with summation notation, you're probably thinking, wait, alpha, what if it's side length 1 and alpha, so alpha is going to equal 1 here. You know, what if it's HB1? So 1 minus 1, that's 0. K equals 1. One of the quirks about summation notation is, in this case, this whole, whatever's in your summation notation, that step equals 0. You're basically, this is the kind of crummy thing about the summation notations here. You're basically starting from scratch. Let's say you want to get like the HC of, let's say, this side right here, side length 3, right? If you want to get HC3, when you follow the summation, obviously when you solve it yourself, you're not going to start from scratch each time. You're going to know it's going to be SLK times the sine of phi k plus the previous stuff, okay? You're going to know that. But if you follow it here, it's like, to get this little thing, you have to go all the way from the beginning to get there. And then the same thing for the next side. You're starting from scratch, but when you use this, you know, you guys will use your brains. So you're going to know, like, how to save some effort, right? So this HB plus HC side, it's simply, I'm not going to draw it out. Okay, this video is probably rambled on for enough time. It's simply what I wrote previously as HC alpha plus this. So you know, after the equal sign. So the previous, when it was HC alpha plus this. All right. That's what's going to be HB plus HC. And for the next video, I'm going to mush it up all together into the counter equation. So stay tuned for that. Bye-bye.